start with again. So today we'll start again from the same point where we left already. That is the three-stage nuclear technology. We'll talk about little bit on that. So nuclear energy, if you see, it is the fifth largest source of electricity for India, which is contributing around 3% of the total electricity generation in the country. That means still we are depending on what? Fossil fuels. But generally the fossil fuels is not a good thing on to that we need to depend upon, right? Let's suppose we are using coal and all. So that is not good because environment pollution will be there. So we should think of renewable source of energy. So if we will try to think of renewable source of energy, that means, see, if you see we are using what? Fast days only, right? And fast days we try to talk about, we are getting very few amount of like some 20 giga
12 gig, 12
sorry 12
gigawatt
12 gigawatt of electricity we are getting for next
years,
30 years or 20 years.
30.
30 years, right? Okay. So if you see now, if we can achieve to that stage 3, there we can produce more. Am I audible?
Yes, sir.
Okay, give me a second. I see a drop in internet connection. Give me 1 minute, okay? I will properly, because my laptop screen got disconnected. Okay. Hope I am audible, right?
Yes, sir.
So we try to talk it like if we are able to achieve the stage 3, then we can make it more than 3%, which where we will try to have a less dependency on the fossil fuels. So India has over 22 nuclear reactor in seven power plants, right, across the country, which produces around 6,780 megawatt of nuclear power. In addition to Kakrapara Atomic Power Project, that is KAPP3, India's first 700 megawatt electricity unit and the biggest indigenous developed variant is the PHWR. So PHWR is nothing but pressurized heavy water reactor. Okay, because we already saw the different type of reactor. One is like boiling water reactor. I can write BWR,
Pressurized
pressurized water reactor, then pressurized
reactor.
heavy water reactor, boiling heavy water reactor, fast breeding reactor, right? And we try to talk about in stage 3, we are going to use advanced, right?
Technology.
Yeah. So here we are trying to do, so Kakrapara Atomic Power Project, there we are trying to generate what? 700 megawatt of electricity. And this is the first indigenous developed, but what Kakrapara they use is pressurized heavy water reactor. So 18 reactors are pressurized heavy water reactors. So out of 22 nuclear reactors, out of 22, there are 18 which are pressurized heavy water reactors and 4 are light water reactors, means normal boiling water reactors. Is that clear? Okay. Recently, development government allowed joint ventures with PSUs to enhance the India's nuclear program. Nuclear Power Corporation of India Limited, we already saw Nuclear Power Corporation of India Limited, right? NPCIL is now two joint venture with National Thermal Power Corporation of Limited, that is called NTPC, and we are having one Indian Oil Corporation Limited, that is IOCL. So basically, this is the recent development that NPCIL have a joint venture with National Thermal Power Corporation Limited, that is NTPC, and Indian Oil Corporation of Limited. So if you see, there are 22 there are 22 nuclear reactors of India around 2021. So out of 22, what we told is there are 12, right? There are, sorry, 22. Out of 22, there are 18 which is on which reactor? Pressurized heavy water reactor. Okay. And out of that, if you talk about Kakrapara, right? Kakrapara reactor. So Kakrapara जोटा कि अच्छी हमारा कोटी ना गुजरात रे सी जनरेट केते करछि ना 700 megawatt of electricity that is we are getting from Kakrapara, right? And how much it behaves which reactor? It uses which reactor technology? Pressurized heavy water reactor.
Water reactor.
Next, expansion of nuclear installations. So in past, India's nuclear installations were mostly located in South India. Generally, it was in South India or in Maharashtra or in Gujarat. So now, what we are trying to think is, we try to enhance it in the eastern side also. Okay. However, the government is now promoting its expansion to other parts of the country. As an example, the upcoming nuclear power plant is in UP, but we have to see. Okay, so they are trying to make a nuclear power plant in Gorakhpur. Presently, they are talking about is it in Haryana? Maybe there is a different Gorakhpur, which will become operational in the near future. India's indigenous move. So the world's first thorium based. And when you are saying thorium based, which kind of reactor it will be? It will be mostly second and third stage, correct? No, in second stage it is related to plutonium 239, but there we were adding what? Thorium,
32.
correct? So thorium 232 you are adding, and this behaves which reactor? It use which reactor? Fast breeder reactor.
Fast water reactor.
That means there will be thorium which will be behaving as a fertile material. Then because of plutonium 239, which is a fissile material, it will generate neutrons. That neutrons will try to hit the thorium fertile material, fertile to fissile. Then the reaction will continue. Similarly, it will go to uranium 233. This fertile material thorium 232, when it will become fissile, it will become uranium 233, which will be the next stage called stage 3.
Advanced stage.
Advanced reactor रे आम्ही use करूया. Okay. Then the world's first thorium-based nuclear power plant, that is called Bhavani. What is the thorium-based nuclear power plant? Bhavani. It is using uranium 233, which was like third stage, is being set up at Kalpakam in Tamil Nadu. This plant will be entirely indigenous and will be the first of its kind. See, generally it is going to become a third stage reactor because you are going to use thorium-based nuclear power plant based, which is called Bhavani, and it is using what? Uranium 233. The experimental thorium plant Kamini already exists in Kalpakam, because there is already experimental plant that is called Kamini, but the one that will be in operational, that is nothing but that is Bhavani. So Kamini, Bhavani, these two are clear. These are reactor, nuclear reactor. It is based in Kalpakam, which is in Tamil Nadu, right? And it will behave in the stage 3 nuclear reactor, right? Which will use thorium, or basically thorium based, and it will have uranium 233 as the fertile material. Sorry, fissile material. Hope it is clear, right? Kamini, Bhavani. Don't consider this Kamini, Bhavani as some missiles or some like rockets or something. Okay, these are nuclear reactor. Okay. India's plans to expand nuclear energy share. So, as per Ministry of Power, nuclear energy will soon emerge as one of the most important source of alternative clean energy for increasing power demand of India. India is counting on its nuclear program to help meet the commitments under Paris Agreement, because in Paris Agreement, environment related, right? So you already know, like we are going to have a like we try to set a target, like we will have zero emissions, right? That means also because of the Paris Agreement, which was adopted by 196 countries, then we have COP21 in Paris to reduce 35% of the emission intensity by GDP by 2030. Because we have this agreement, somehow we need to think of renewable source of energy. And to make renewable source of energy, definitely we require these nuclear reactors. That means if we can try to focus on this nuclear reactor, we can make it, we can actually try to achieve this target. Is that clear? Okay. Then the nuclear power plants have so far generated about 755 billion units of electricity, saving about 650 million tons of CO2 emissions in this country. That means through the nuclear power plant, we could able to reduce the CO2 emissions. Several measures to enhance the generation from the nuclear power plant in the country were taken, including administrative approval and financial sanctions for 10 indigenous 700 megawatt pressurized heavy water reactors. So that means we are trying to take lot of administrative approvals as well as also because this nuclear reactor is not a small thing to do, right? It requires huge amount of financial support also. So that also we try to get it so that we can again we can add 10 more indigenous 700 megawatt pressurized heavy water reactor. Currently, how many we have? 22. Out of 22, 18 are pressurized heavy water reactor and 4 are light water reactor. Clear? Okay. In principle, approval was given for setting of 6 advanced pressurized water nuclear reactor at Jayatpura in Maharashtra with 1650 megawatt each with cooperation from France will make it the largest power generating site with a total capacity of 9900 megawatt of electricity. So now the new factor is Jayatpura. There we are going to have a advanced pressurized water reactor, water nuclear reactor. Okay. The government has also amended the Atomic Energy Act to enable joint venture of public sector companies to set up nuclear power projects. See, we require now to achieve that 2030 target, right? Ki 35% GDP carbon emission has to be reduced, right? That means we require more and more renewable energy. And to have more and more renewable energy, we need to set up more and more nuclear power reactors. Nuclear power reactor ତିଆରି କରିବା ପାଇଁ ଆମ ପାଖରେ ସଫିସିଏଣ୍ଟ ଆମାଉଣ୍ଟର ଅର୍ଥ ଥିବା ଦରକାର କିନ୍ତୁ କଥା ହଉଛି ସେମ୍ ଅର୍ଥକୁ ପୁଣି ଆମକୁ ୟୁଜ କରିବାର ଅଛି ଗରିବୀ ହଟାଇବା ପାଇଁ ରାଇଟ୍ ଫର ପଭର୍ଟି ଇରାଡିକେସନ ଡିଫରେଣ୍ଟ ସ୍କିମ୍ ହେଲ୍ଥ ସେକ୍ଟର ଏଜୁକେସନ ସେକ୍ଟର ବହୁତ ସାରା ସେକ୍ଟର ଅଛି ସେଗୁଡାକୁ ବି ଦେଖିବାକୁ ପଡିବ ତେଣୁ ଗଭର୍ଣ୍ଣମେଣ୍ଟ ଟ୍ରାଏ କଣ କରୁଛି ଯୋଉ ଆଟମିକ ଏନର୍ଜି ଯୋଉଥିରେ କି ଆମେ ଟ୍ରାଏ କରୁଥିଲେ ଏଫଡିଆଇ ବଗେରା ଇନଭେଷ୍ଟମେଣ୍ଟ ନ କରିବା ପାଇଁ ସେଥିରେ ସେମାନେ ଟ୍ରାଏ କରୁଛନ୍ତି କି ଧୀରେ ଧୀରେ ପବ୍ଲିକ ସେକ୍ଟରକୁ ବି ଆଲାଉ କରାଯାଉ କି ଯୋଉ ପବ୍ଲିକ ସେକ୍ଟରରେ ଡିଫରେଣ୍ଟ କମ୍ପାନୀ ମାନଙ୍କୁ ସେମାନଙ୍କୁ କୁହାଯାଉ କି ତମେ ମାନେ ସେଟଅପ୍ କର ଆଣ୍ଡ ଯଦି ଦରକାର ଧୀରେ ଧୀରେ ଫରେନ ବି ଆମକୁ ପଇସା ଆଣି ହବ. So from the present nuclear power capacity, we have nuclear power capacity is 6,780 megawatt. It is expected to increase to 22,480 megawatt by 2031 on completion of all these 6 advanced pressurized water reactor bagara jati ame start kar dele then eguda sabu complete hejo and ame paijiba kebe na by 2031 we can able to achieve a target of 22,480 megawatt of electricity. Given the issue associated with nuclear power, it is debatable if the nuclear power is still viable choice for India. Because the issue, what will be the issue? कि जदि explosion है या फिर radioactive जो material होड़ा because uranium 233 you are using right जदि somehow leakage है then that entire area right से पाखापाखी जो city वगैरह जहाँ थी वो सब कुछ नष्ट हो जाएगा. So cost of establishing nuclear reactor has increased by at least fourfold in last decade. Last 10 वर्ष भितर जो cost of like गोटे न्यूक्लियर पावर प्लांट को इस्टाब्लिश करबे जति पैसा दरकार सेटा लगभग 4 गुण बढ़ी गलानी. Delay in completion of proposed project as per the unit cost of nuclear power compared to the decreasing cost of renewable energy. Vulnerability to disasters and wars. So because suppose tomorrow nuclear reactor, for example, you remember in Ukraine and Russia war. So generally Russia जदि try करिवो nuclear reactor को ऊपर war कर देवा ପାଇଁ जोटी तार nuclear reactor अछि then it is vulnerable for war, right? काउंट से रेडियो एक्टिव जो मेटाल गुड़ा अच्छा सेगुड़ा एक्सपोज हो बाहर को जब एक्सपोज हो देन तुमको आ बम पकेबार ना बाय डिफॉल्ट ताकू नष्ट कर सेटा ही जदि नष्ट करदब सेटा ही गोटे बम भलिया काम करबो. सो इन द कॉन्टेक्स्ट ऑफ थ्रेट फेल्ड टू द रिएक्टर्स इन यूक्रेन एक्सप्लोजन नियर टू जापोरजिया and Chernobyl power line cuts. तो एगुड़ा होची तम पई थ्रेट आसीबो इन फ्यूचर जदी बिकॉज़ दिस इज रिलेटेड टू न्यूक्लियर टेक्नोलॉजी राइट जो थ्रे कि तमे यूज करूचो गोटे माने मटेरियल जोगुड़ा कि हाईली एक्सपोजेबल टू द आउटर साइड लाइक एटमॉस्फेयर राइट जो थ्रे कि बहुत किछि प्रॉब्लम आस जाय पारे सेति पई एगुड़ा होची vulnerable to disaster as well as war. Any doubt in nuclear reactor? So we completed. So these last 2-3 slides, right? These were related to mains related content. So I will provide you just make a note of it. Okay. But prelim related content gonna ki ama pakhre ketata nuclear reactor achi that is around 22. Out of 22, how many are pressurized heavy water reactor and how many are light water reactor? Then what is heavy water reactor, what is lightweight reactor, what is boiling water reactor, boiling heavy water reactor, fast breeder reactor, then Bhabini, sorry, Kamini and Bhabini. What is that? Bhavani, right? Is that Bhavani? Yes. Bhavani, Bhavani, not this is Bhavani, okay? So Bhavani and Kamini, these are the two. One is Bhavani, it is related to third stage. This is again prelim material. Kamini, that was experimental, okay? And where it is established? Kalpakam. And where is Kalpakam? Tamil Nadu. Is that clear? Okay. Next. So we talked about fission. Now the next concept is fusion. So Bartan ame asiba hydrogen bomb related. See, fission is not related to hydrogen bomb because fission is related to uranium 235, correct? No, uranium 235, uranium 238, जो कि uranium 238 थिला and से uranium 235 रो concentration 0.7 थिला. That is what we are trying to thought of fission. जो गोटे न्यूट्रॉन जस्ट तमे गोटे स्लो मूविंग न्यूट्रॉन ऐड करथलो जोटा कि गोटे फिजाइल मेटेरियल सहित रिएक्शन करिकी से वर्तमान कोन करथला सफिशिएंट अमाउंट रो एनर्जी जनरेट करथला. नाउ द नेक्स्ट कांसेप्ट विल बी न्यूक्लियर फ्यूजन. So this nuclear fusion happens in sun basically. सूर्य different different बड़ा बड़ा planet तो सेठी जो reaction हुए that is a fusion reaction not fission reactions because hydrogen is readily available in the atmosphere not uranium, correct? No, uranium is uranium readily available in the atmosphere? No.
Also,
So that's why we will talk about hydrogen जेतला आसी सूर्य रा एनर्जी हाइड्रोजन थी तो आमे कथा हबा कोन ना न्यूक्लियर फ्यूजन एंड ए फ्यूजन रो आमे आगो जिवा कोन ना हाइड्रोजन बम. So it is the process where two lighter nuclei combine to form a heavy nucleus. तो सेठी कोन थिला गोटे हेवी न्यूक्लियस थिला सीए भांगुतिला बेरियम एंड क्रिप्टन रे, राइट? But here two small nuclei they will combine and they will form a bigger nuclei. So two lighter nuclei they will combine and they will form a heavy nucleus. So this is what we are trying to talk about from the perspective of hydrogen bond. We will try to see it. So if you talk about hydrogen and hydrogen, if they will combine they will form helium. Like not exactly they will combine and they will form helium. Basically what we are trying to say is, let's suppose there is a hydrogen and okay, what is deuterium and tritium? Normal hydrogen,
isotopes,
correct?
isotopes of the hydrogens.
Isotope the hydrogen. So 1 and 2, here 2 is nothing but the atomic mass. That means there is one proton and one neutron. In normal hydrogen, do we have neutron?
No, sir.
Okay, so that's why you will see deuterium is nothing but hydrogen having one proton and one neutron, that is called deuterium. Similarly, tritium. Tritium is nothing but hydrogen having one proton plus two neutron. So whenever these two they will combine, deuterium and tritium, what will happen? Now they have here this deuterium has one proton. Similarly, tritium has one proton, but here one neutron and two neutron of tritium. Total three neutron. That means two proton. I am mentioning, let's suppose this is the new element which will be formed. Two proton. That's why I mentioned two. And here the mass I am mentioning 5, correct? No, because 3 neutron plus 2 proton, so 5. So what I can donate here, it can be x24 plus 1 neutron. Can I mention it something like this?
Sir,
Okay, then what the x it will be? It will be nothing but helium. That's what 2 proton and 2 neutron, helium and 1 neutron got our. So this is what, whenever there is a bond formation, this require energy, and whenever there is a whenever they are now going to combine, right? Why they want to combine? Definitely you need to provide energy such that there will be a reaction, otherwise there won't be any reaction. So once ସେମାନେ combine ହେଲା ପରେ ଯେତେବେଳେ ନୂଆ bond formation ହବ ସେତେବେଳେ ବି ସେମାନେ energy release କରିବେ. So don't release any radioactive waste. But in case of uranium, in case of fission, we had radioactive waste. There was radioactivity metals, right? Uranium 235, those are radioactive metals. Okay, so this will provide unlimited clean energy due to more hydrogen in atmosphere, so no need of mining also. In case of uranium, you need to mine the uranium and you need to get uranium 238 and 235. So jodi तुमको actually reactor रे यूज करियार अछि you are going to get uranium 235 नहल तो जदि 238 आनलो ताकू तुमको यूज करिया पड़ियो गोटे फास्ट मूविंग न्यूट्रॉन सहित जोठी भी तुमको एनर्जी दाव पड़ियो सफिशिएंट अमाउंट रो बट fusion is something it will give clean energy that can go for exposing hele radioactive metal expose hobo but ethi radioactive metal hi kichi nahanti because we are just normally using hydrogen is that clear okay and here it will provide the fusion will provide 4 times more energy compared to uranium fission is released तो यूरेनियम फिजन रिएक्शन रे जति एनर्जी रिलीज होता जदि x टाइम्स एनर्जी रिलीज होता एटी 4x हम बट टिल नाउ वी डोंट हैव एनी फ्यूजन रिलेटेड रिएक्टर्स ओके तो आम पाखे फ्यूजन रिलेटेड रिएक्टर ए पर्यंत नाही एंड फ्यूचर रे खाली आम पाखे नो अलग कंट्री पाखे भी नाही सो एवरीवन इज गोइंग थ्रू द fission reaction all the nuclear reactor is related to fission reactions now the next question is fusion is spontaneous fusion reaction spontaneously we need to force them as like charges repel each other so like charges repel each other because what we are trying to talk about we are trying to talk about there is deuterium there is tritium already they माने से माने निजे निजे भीतर स्टेबल अछन बोले से माने ऑलरेडी अछन बट तमे कहउछ से माने दी जण आनी कि रिएक्ट करिवो काहे से माने रिएक्ट करिवे तो जदि तुमको एनर्जी देवाक पड़ो तुमको दी जण को आनी कि रिएक्ट करियो पड़े बिकॉज अगेन आ पाखरे भी पॉजिटिव चार्ज आ पाखरे भी पॉजिटिव चार्ज मान तो रिपेल करिवे तो कथा होची से मानको रिएक्ट करिया को तुमको सफिशिएंट अमाउंट रो एनर्जी देवाक पड़ो सो the stars get the energy due to gravity which is pulling all the materials towards the center तो ई बर्तन नॉर्मल भाबिनियो सन केस नहीं जाओ ओके सूर्य रो केस नहीं जाओ सूर्य केस रे लेट्स सपोज देयर इज हाइड्रोजन रो ड्यूटेरियम एंड ट्राइटियम ओके दीटा को अछंदी किंतु से नॉर्मल स्टेज रे बुलुचंदी किंतु बिकॉज ऑफ सन रो हेवी ग्रेविटी लागी से भिडी आनी कि तांको बहुत जोरे बाड़े देला पर गोटे रिएक्शन हबो से रिएक्शन रे एनर्जी रिलीज हबो से एनर्जी सफिशिएंट अगेन हबो पुनी आउ दीटा ड्यूटेरियम एंड ट्राइटियम को भिडी के आनी कि पुनी हीलियम जनरेट करिया पई अगेन कोन हबो ना हीलियम आउ हीलियम अगेन ए माने पुनी माड हेबे ए माने पुनी आउ गोटे हायर एनर्जी बनेबे यू अंडरस्टूड राइट कि फ्यूजन रिएक्शन केमिति स्टार्ट हो एंड आमे कथा होल ना इन द बिगिनिंग आयरन जाय पळेबे देन सफिशिएंट ग्रेविटी नाही बिकॉज से माने जो आसुथिले कहा संस्पर्श रे आसुथिले ग्रेविटी संस्पर्श रे आसुथिले बोली ग्रेविटी आनी कि से मानु रिएक्शन करे दोतला किंतु जेतले से माने बिगर एंड बिगर एलिमेंट बनी चलिबे ग्रेविटी आ सफिशिएंट हबनी ग्रेविटी रो फोर्स आ सफिशिएंट हबनी से मानु आनी कि कंबाइन करी रिएक्शन करिया इज दैट क्लियर that we talked in the first thing okay so now it requires energy let's suppose that energy is x now they will release the energy called y so this y will be greater than x कि आमे को मुसे या कहली ना फर्स्ट ए दीटा को जेतेले आमे नै के आसीबा हमको एनर्जी दरकार बिकॉज़ ए माने ऑलरेडी स्टेबल फॉर्म रे अछनी तो ए जो एनर्जी इन केस ऑफ स्टार्स हाउ दिस एनर्जी इज कमिंग इन फॉर्म ऑफ ग्रेविटेशनल फोर्स तो ग्रेविटेशनल फोर्स लागि ए माने कोन करछंदी भिडी की नै आछंदी ए दी जण नै के आसिला पर रिएक्शन होची रिएक्शन हला पर गोटे एनर्जी रिलीज होची लेट्स सपोज दिस एनर्जी इज y एंड दिस ग्रेविटेशनल फोर्स रो जो एनर्जी आछती दैट इज लेट्स सपोज x तो वी आर सेइंग y इज ग्रेटर देन x जोथि बैंकी रिएक्शन ता आगु आगु स्पॉन्टेनियस ही चलिबो ओके सो हाइड्रोजन बम फर्स्ट blast atom bomb get energy used in hydrogen bomb for getting energy to start the reaction so in case of hydrogen bond what you are trying to do is first hydrogen bomb हवा पई हेले फर्स्ट तमे कोन करछो ना गोटे एटम बम आनो से एटम बम लेट्स सपोज तम पाखरे केवल हाइड्रोजन अछि यू अंडरस्टूड यू हैव ओनली हाइड्रोजन नाउ व्हाट यू विल डू कि जदि आठू तुमको एनर्जी आनिबार अछि ए दीटा को रिएक्ट करले पर से माने जो रिएक्शन हे गला पर हीलियम हे जिवे से माने किसी एनर्जी प्रोवाइड करिवे किंतु एमाने केतले एनर्जी प्रोवाइड करिवे जेतले एमाने रिएक्शन होबे किंतु ए रिएक्शन हबा पई ही हमको एनर्जी दरकार तो से एनर्जी तमे कोठु आनिबो ना ए हाइड्रोजन को गोटे कंटेनर भितरे नियो लेट्स सपोज ए कंटेनर भितरे खाली हाइड्रोजन अछंती नॉर्मल रिएक्ट करिवेनी ए भितरे तमे ब्लास्ट कर दियो गोटे एटम बम मानो एंड एटम बम टा को ब्लास्ट कर दियो जदि तमे एटम बम द्वारा ब्लास्ट कर देलो सेही एटम बम सफिशिएंट अमाउंट रो एनर्जी रिलीज करिवो जोथरे कि हाइड्रोजन आसी स्टार्ट हेबे कंबाइन हेबे एंड से माने कंबाइन हेबे हीलियम ये कंबाइन हबो हीलियम देन अगेन ए हीलियम से माने कंबाइन हेबे देन से माने नेक्स्ट 4 टाइम्स वाला बनेबे एमिति कंटीन्यूअसली से माने बनै बनै चलिबे इज दैट क्लियर जे पर्यंत तमे एनर्जी दवनी से पर्यंत रिएक्शन भी होबनी ओके सो व्हाट इज द सोर्स ऑफ एनर्जी इन द रिएक्शंस सो मेजर चैलेंज इन द वर्ल्ड still we are struggling we need atom bomb for fusion not just fission reactions 90% uranium 235 is required. That means you understood like why we don't have fusion reactor. Fusion reactor को start हुआ पे हेले हमको गोटे atom bomb दरकार and atom bomb माने गोटे weapon grade रो bomb correct no weapon grade केतला हबो जेतले uranium 235 90% थिवो. That means तमे कहू जे गोटे nuclear bomb नै कि गोटे attack करो सेही जो कंटेनर भितरे ताकि सेठी sufficient amount रो energy release हबो जोथि कि तमे बनेबो कोन hydrogen. Is that clear? Okay. So we are trying to achieve fusion reactor. Not only India, but entire world does not have it. Fusion reactor, no one has it. We are trying to achieve that, but that is a long story. We could not able to achieve it because we required an atom bomb. Atom bomb को fuse कला परे, not fuse basically, atom bomb को basically blast कला परे, ता परे जाई कि तमे hydrogen bomb काम होई परिबो नहले हबो नै. Why? Because the energy needed for fusion we require high activation energy, and this energy can be provided only through fission reactions, and fission reaction bomb through. So it is necessary for fusion as both the positively charged nuclei repel each other. एठी गोटे तमे हाइड्रोजन पॉजिटिवली चार्ज एपटे गोटे हाइड्रोजन पॉजिटिवली चार्ज ए दि जण सेमिति रे भी निजको निज रिपेल करिवे करेक्ट पाकु गान लाडको तेनु तांकु जदी लगे कि गोटे रिएक्शन करिया चाहौ देन सफिशिएंट अमाउंट रो तुमको एनर्जी दबाउ पड़िबो. However, whenever the fusion takes place, more energy is released than the invested. The reaction is exergonic. Means exogenic. Means exothermic reaction. Means the energy. What is exothermic and what is endothermic? There are two type of reactions, right? Endothermic in the sense to start the reaction you are giving, let's suppose 100 kilojoule of energy. But once the reaction completes, there is a release of 50 kilojoule. Means reaction हे सारा पर 50 किलोजूल बट स्टार्टिंग रिएक्शन होआ कोले तुमको 100 किलोजूल दवा पड़तला. दैट मींस तुमको से रिएक्शन अधिक एनर्जी कंज्यूम करूची रादर देन अधिक एनर्जी प्रोड्यूस करबा बदले हां कि नहीं. दिस इज कॉल्ड एंडोथर्मिक रिएक्शंस. व्हाट इज एक्सोथर्मिक? लेट्स सपोज मु 100 किलोजूल रो एनर्जी देली बट प्रोड्यूस कला 200 किलोजूल रो एनर्जी. दैट मींस मु 100 किलोजूल एनर्जी एक्स्ट्रा पाइली. So if you are getting more energy from whatever you are giving, so देइथिला तमे 100 किलोजूल आमे फिजन रिएक्शन रे देइथिले केते, लेट्स सपोज x अमाउंट रो एनर्जी बट प्रोड्यूस होजी 2x अमाउंट रो एनर्जी. So generally कोन हमना एथिरे अधिक रु अधिक एनर्जी प्रोड्यूस हो. That's why the first statement, if you remember, in case of fusion it is 4 times more energy it will produce than the fission reactions. हां कि नहीं? Okay. So it is called exothermic reactions. So in stars, the enormous pressure and energy of gravity provides the activation energy. तो stars रे जो सूर्य कथा कहउछ तमे, सूर्य भितरे जो हाइड्रोजन हीलियम एमानकर जो रिएक्शन होची तो तांको भितरे जो एक रे तो हीट अछि, सफिशिएंट अमाउंट रो हीट अछि, एंड से हीट को थ्रू जनरेट हिची एई माने सब रिएक्शन करछन बोली हीट कंटीन्यूअसली जनरेट ही चालू. तो सेठी एक रे तो प्रबल जोरे प्रेशर and प्रबल ग्रेविटी. बिकॉज ऑफ दैट से माने कोन करछन भिडी आउछन काहा को ए जो हाइड्रोजन हीलियम भले जो एलिमेंट वाला ताको आनी कि रिएक्शन करके सफिशिएंट अमाउंट रो एनर्जी कमौछन. सो इन हाइड्रोजन बम द एक्टिवेशन एनर्जी इज प्रोवाइडेड बाय द एक्सप्लोजन ऑफ ए फिजन बम to heat the reaction to a temperature about 10 to the power 8 Kelvin. You can think of what is 10 to the power 8 Kelvin. Here in Odisha, if you see today's 40 degrees Celsius. So I am saying 10 to the power 8 degree Kelvin. Kelvin वगैरह सोचे ताको equivalent करिवो से Celsius related. You can think of almost equal to 10 to the power 8 degrees Celsius, right? You just think of that temperature. That temperature require for hydrogen bomb require the activation energy. So जो थी हमको गोटे fusion bomb means गोटे atom bomb दरकार. So this technology when used in fusion reactor offers great promise as deuterium and tritium are available in unlimited amounts. The technology is environment friendly and as end product is helium. There is no radioactive radiations. Huge amount of energy can be obtained from a small amount of fuel. But तापाई दरकार होची कोन हमको atom bomb सहित खेलिया पड़ियो. First atom bomb रे तमे blast करो ता पर जाय कि हाइड्रोजन. बर्तन तमे मते को atom bomb तमे केउठी blast करबो. And जदी टिके लीकेज हैला in the beginning somehow miss like management हैला and atom bomb रो लीकेज हे गला हाइड्रोजन बम बदल रे से सिटी विटी सब ध्वंस हो जायो. Correct? Any doubt why we don't have fusion reactor till now? Because the activation energy itself requires atom bomb. Hope it is clear, right? Okay. Next. International Thermonuclear Experimental Reactor, that is called ITR, International Thermonuclear Experimental Reactor. So what it is? So it is an experimental fusion reactor. This is an experimental fusion reactor facility under construction in Cadarac, south of France, to provide the feasibility of nuclear fusion for future scope of energy. So we are trying to achieve, but that's why we are having a experimental reactor that is called International Thermonuclear Experimental Reactor. So many countries, because ଏଠି କୋଉ ଗୋଟିଏ କଣ୍ଟ୍ରି ସେ କରିବନି କାହିଁକି ନା ତା ପାଖରେ ଏତିକି ପଇସା ଆସିବନି କି ହଁ ଚलो ସବୁ, ତ ସେ ତାକୁ କରିବା ପାଇଁ ବହୁତ ସାରା କଣ୍ଟ୍ରି ସପୋର୍ଟ କରିବେ। ତ ଆଇଟିଆର ର ପାର୍ଟନର କିଏ? ବିକଜ ଦ୍ୟାଟ୍ସ व्हाई इफ यू सी द वर्ड कॉल्ड इंटरनेशनल, दैट मीन्स କିଛି ସବୁ ଦେଶ ମାନେ ମିଶିକି କରୁଥିବେ। ସୋ ଇନ୍ ଆଇଟିଆର ପାର୍ଟନର୍ସ ଆର୍ ୟୁରୋପିଆନ ୟୁନିୟନ, China, India, Japan, South Korea, Russia, United States of America. That means all big countries like USA, Russia, China, EU, India, Japan, South Korea, all are there. European Union being the host party because it is in France. So European Union is the host country. It contributes around 45% to this, whatever the cost of that, while the rest of the parties contribute 9% each. Most of these contributors are through in kind procurement of ITR components. तो ITR जो प्रोजेक्ट रे जो जो डिफरेंट डिफरेंट रिक्विपमेंट गुड़ा रे जहाँ दरकार से जो कंपोनेंट गुड़ा यूज होची से कंपोनेंट गुड़ा को अलग कंट्री माने से माने ट्राई करछन सपोर्ट करिया पे। इंडिया formally joined the ITR project in 2005 and the ITR agreement between the partners were signed in 2006. So the rest of the party, they will try for manufacture of the component required and share them with the European Union. So European Union, they are spending how much? 45%. Other partners, they are providing 9% is through what? Now through the manufacturing of different component of the ITR. Is that clear? So this is the experimental thermonuclear reactor. Okay, जोटा की fusion reactor बढ़िया काम दबो. But this is experimental. Till now, there is no operational fusion reactor. Hope it is clear. भाई बाबा मु गोटे कंटेनर भितर मते ब्लास्ट करियार अछि गोटे एटम बम, दैट मीन्स से कंटेनर 10 टू द पावर 8 डिग्री सेल्सियस जाय मेल्ट हो नथियो, मते से भलिया जिंस दरकार। तो ता पई जो कंपोनेंट गुडा दरकार से गुडा को बनेया पई अलग कंट्री जो माने 9% ईच लाखे को शेयर करूचती अदर देन यू से माने ट्राई करूचती तार डेवलपमेंट पई। सो आईटीआर ऑर्गेनाइजेशन इज द सेंट्रल टीम रेस्पोंसिबल फॉर कंस्ट्रक्शन एट साइट and operation, while ITR partners created their own domestic agency to deliver their commitment to ITR. It has a 5-year assembly phase, plans to reach its maximum power output by 2035. We cannot get commercial level reactor by then. That means 2035 से एक्सपेरिमेंटा कंप्लीट हबो, बट once the experiment success hela, then we can think of, after that we will think of actually commercial level ro आमे फ्यूजन रिएक्टर, बट से पर्यंत तो आमे कमर्शियलाइज तो करि ही परिबानी। सो दिस असेंबली ऑफ रिएक्टर बिगन इन जुलाई 2020। आईटीआर इंडिया अंडर इंस्टीट्यूट फॉर प्लाज्मा रिसर्च गुजरात, पार्टनर एलएनटी, डिलीवर्ड क्रायोस्टाट whose function is to provide cooling to the fusion reactor to keep very high temperature at its core under control. Because I already told कि भाई गोटे कंटेनर रे 10 to the power 8 डिग्री सेल्सियस थिबो टेम्परेचर, ताहाली that is the activation energy required for hydrogen bonding, basically this fusion reaction to start। 10 to the power 8 को एते मात्रा हीट जनरेट हबो, ताकू कूल करिया पई भी सी कथा तो इनिशियली 10 to the power 8 कहू जी मु फ्यूचर रे केते मात्रा टेम्परेचर जनरेट हबो, 10 to the power आमे जति की एनर्जी दवा ताटू अधिक एनर्जी रिलीज भी हबो। दैट मींस ए जो टेम्परेचर बढ़ी बढ़ी चलियो, हां कि नहीं? दैट मींस तमे गोटे कहिया गेले गोटे सूर्य तयारी करिया जाउछो एंड दैट टू पृथ्वी रे गोटे सूर्य भलिया तापमात्रा रखिबो जोटा की गोटे तमे पृथ्वी रे तयारी करे। यू अंडरस्टूड राइट द डिफरेंस बिटवीन फ्यूजन रिएक्शन एंड फ्यूजन रिएक्शन? Fusion is all about like sun bhitere jo jinsa guda house, that is related to fusion. Why we don't have fusion reactor? You understood the concept, because the activation energy is high and once that is supplied, further reaction basically jo energy generate hoga that will be still more high and the temperature will keep on increasing. So taku cool kariya pai sufficient amount ra like we should have proper component, jothi pai ki India ra component jota dekhiba cryostat, what it will do, it will try to cool down the internal, basically से जो हाई टेम्परेचर थिबो कोर रे जो जोठी रिएक्टर टारे ताकू कूल डाउन करिया पे हमें इंडिया कोन ट्राई करछि डिलीवर करिया पे cryostat and already delivered. Is that clear? ITR, International Thermo Experimental Reactor, Thermonuclear Experimental Reactor. So the reaction takes place in deuterium and tritium plasma, that is ionized electrons released by the atoms and the deuterium and tritium nuclei. The activation energy is provided by heating the plasma to a temperature of about 100 million degrees centigrade by injecting high energy neutral particle beam or radio frequency wave from outside which get absorbed by the plasma. Plasma means already ionized wala particles, right? And sethire tome 10 to like 100 million degree Celsius ର temperature provide କରିବାକୁ ଯାଉଛ through what? Na injecting high energy neutral particle beam. So under these conditions nuclei can overcome repulsive force. से जो हाइड्रोजन ताको भितर जो पॉजिटिवली बोथ आर पॉजिटिवली ताकू तुमको रिपेल जो करूथिले ताकू तुमको हटेया पई तमे सफिशिएंट अमाउंट रो टेंपरेचर दोछ कि से रिपेलिंग फोर्स टा कमी जाऊ and fuse releasing huge amount of heat energy. At this temperature the wall of the reactor would melt. This is the issue. By 10 to the power 8 degree Celsius से टेम्परेचर रे जो तमे कंटेनर बने थो से सब गुडा मेल्ट हो जिवो. Therefore the plasma is kept in motion in ring shape magnetic field. जदि तमे देखियो this is how it looks like. कि ताकू जदि तमे रखी देलो ताहले से तो मेल्ट कर दबो. ताकू जदि तमे कि बुलेइबो जदि ताकू गोटे जगह रे कंटीन्यूअसली न रखी कि से बुलुथिबो देन मे बी सरफेस सहित न लागिबा दरकार से. जदि सरफेस सहित लागि गला से टेंपरेचर पे जति टेंपरेचर अछि ना से सरफेस एमिति कोनोसी टेंपरेचर लाइक सरफेस दबनी जोटा कि तम मेल्ट हबनी से मेल्ट ही जिवो. So ITR has been designed to produce 500 megawatt of output power for 50 megawatts of input power for up to 400 seconds. कि भाबो आम पाखे 700 मेगावाट रो इलेक्ट्रिसिटी आम जेनेट करूचे थ्रू जो आम पाखे जो प्रोजेक्ट अच्छी काकरापरा राइट 700 मेगावाट ऑफ इलेक्ट्रिसिटी गोटे न्यूक्लियर रिएक्टर आमर जेनेट करूचे एंड एठी 400 सेकेंड रे से 500 मेगावाट दबो. यू अंडरस्टूड द डिफरेंस राइट? Now, the ITR has been designed for developing and testing the necessary technology for energy production, but not for industrial energy production. What it is saying, it is developing and testing the necessary technology. So we are in the testing phase. Okay. So this ITR has been designed. Basically, this ITR is nothing but it is a experimental, but not for industrial energy production. Another 2000 megawatt reactor has been proposed for the continuous energy production. Basically हमको sufficient amount रो energy दरकार जोटा कि से energy को हमें channelize करिवो कोथरे ना ITR को because हमको दरकार सेठी temperature केते 10 to the power 8 बेसिकली डिग्री सेंटीग्रेड दरकार टेम्परेचर ताकू ब्लास्ट करिया पई ब्लास्ट कला पर सेतिकी होची तार एक्टिवेशन एनर्जी जो एक्टिवेशन एनर्जी पाइला पर रिएक्शन ही स्टार्ट हो. So if you see this is how it looks like. There is a vacuum vessel. Okay, this is what there is a vacuum vessel. So deuterium and tritium mixture high frequency radio waves neutral particle beam द्वारा ताकू तमे जदी हिट करिवो deuterium and tritium तांको भितर जो रिपेलिंग फोर्स अछि से रिपेलिंग फोर्स रो अगेंस्ट रे बर्तमान जो हाई एक तो प्लाज्मा अछि से प्लाज्मा को तमे हिट कोथरे करबो ना रेडियो वेव्स विथ न्यूट्रल पार्टिकल बीम एंड विथ हाई एनर्जी ताहाले से माने कोन करिवे दे विल ट्राई टू हीट विथ 100 million degree temperature. It will be the activation energy, then the fusion reaction will start. So basically if you see this magma is consist of what? Deuterium and tritium and एगुडा मूवमेंट करूची काहे कि नहले कोन हबो जदी ई वॉल रे लागिला ए वॉल मेल्ट हे जबो. And because they are moving they will generate strong electromagnetic field to repel the magma in all direction to keep the wall safe, else the wall would melt. Because एमाने ही electromagnetic सी जनरली तमे देखिबो कि को गोटे जिंस को जदी तमे मूवमेंट करोछ काहेंगी मूवमेंट करिया दरकार बिकॉज जेहेतु एगुडा होचंदी कोन प्लाज्मा मींस चार्ज पार्टिकल and because they are charged particle they will generate electromagnetic field. Because they are electromagnetic field तो एठी तमे देखो कॉइल वगैरह लगा हिथिबो तो ए इलेक्ट्रोमैग्नेटिक फील्ड लागी एमाने भी आकु रिपेल करिवे कि तू आसी कि कोठी लागिबोनो सरफेस रे जदी सरफेस रे लागिबो एगुडा सब जळी पड़ी जिवो. इज दैट क्लियर? एंड जदी एमाने मूवमेंट करू न थांदे देन possible ही न थांदा कि इलेक्ट्रोमैग्नेटिक फील्ड रो जनरेशन. होप इट इज क्लियर राइट? मैग्नेटिक फील्ड इलेक्ट्रोमैग्नेटिक फील्ड that is coming because of what? Because of plasma ionized particle, right? Okay. So if you see, there was a question in 2016 UPSC. India is an importer member of International Thermonuclear Experimental Reactor. If the experiment succeed, what is the immediate advantage for India? First one, it can use thorium in place of uranium for the power generation. If you know what is International Thermonuclear the experimental reactor, then you can think like, okay, this is not related to fission, correct? Because thorium, uranium, this is related to fission, right? But what it is related to fusion, correct? So option A is wrong. It can attain a global role in satellite navigation. Where is the use of satellite here? भाई this is related to fusion and କୋଉ ଏମିତି satellite ନାହିଁ ଯୋଉ satellite ରେ କି ତମେ ଆକୁ propellant ଭଳିଆ ୟୁଜ କରିପାରିବ। ଜଣା ପଡିଲା କି satellite କୁ ତମେ ଛାଡୁଛ ବାହାରକୁ, ସେଇଠି ହିଁ ସେ ନଷ୍ଟ ହବ। ଭାଇ 500 କେତେ ସେକେଣ୍ଡ ଥିଲା? 400 ସେକେଣ୍ଡ ନା? 400 ସେକେଣ୍ଡ ରେ 500 मेगावाट ऑफ इलेक्ट्रिसिटी भाविलो 400 सेकेंड रे जना पड़ला कि से 400 सेकेंड रे जो तुम मिसाइल स्टार्ट हेची से 2-3 किलोमीटर 4-5 किलोमीटर जाइथिबो या फिर ताठू अधिक भी जाई पारे पर सेकेंड माने बहुत किलोमीटर स्पीड रे जानदी। तो स्पेस रे भाबो तमे ब्लास्ट करूछो, करेक्ट नो? तो दिस इज नॉट रिलेटेड टू सैटेलाइट नेविगेशन, दैट इज करेक्ट। नाउ it can be drastically improve the efficiency of the fission reactor. It is not related to fission reactor also, correct? This is related to fusion reactor. So it can build for fusion reactor for power gen. See, question will be very simple, like if you think from the perspective of like जदि तमे PY को ट्राई करियो ना देखिया भाई जदि हां फास्ट कथा हला तबे कॉन्सेप्चुअली क्लैरिटी थिबा दरकार। जदि कॉन्सेप्चुअल क्लैरिटी अछि देन क्वेश्चन को से कॉन्सेप्चुअल क्लैरिटी अनुसार सॉल्व करिया दरकार। फर्स्ट ऑफ ऑल यू शुड नो व्हाट इज इंटरनेशनल थर्मोन्यूक्लियर एक्सपेरिमेंटल रिएक्टर। एमिति नो कि मु न्यूज़पेपर रे डेली पढुची हां ठीक अछि किंतु मु जाननी वेदर इट इज यूज्ड फॉर फ्यूजन और वेदर इट इज यूज्ड फॉर फिजन। एंड तमे जानना कि फ्यूजन रिएक्टर रे केते टेम्परेचर दरकार। जना पड़ला से टेम्परेचर को नेकी से गोटे स्टेटमेंट बनै दिछन बट टेम्परेचर रो ना कोठी उठिनी बुझियो ना बुझियोनी। बट लॉजिक तो तमे लगे परिबो कि भाई एते डिग्री टेम्परेचर दरकार एमिति कोन अछि से माने कहबे कि काली ताको हेल्थ सेक्टर रे मु यूज कर परिबे कि इंटरनेशनल थर्मोन्यूक्लियर एक्सपेरिमेंटल रिएक्टर इट विल बी यूज्ड इन हेल्थ सेक्टर आल्सो। देन भाबिनी एठी चारटा ऑप्शन देछि एठी ऑप्शन रे देइथांदा प्राय तो जनरली अछंदी जो माने कहबे कि साइंस एंड टेक्नोलॉजी तुमको तो डायरेक्ट सॉल्व होइजो जदी ऑल ऑफ द अबव मार दबो। ऑप्शन ए 1 and 2, ऑप्शन बी लेट सपोज 1 2 3, ऑप्शन सी ओनली 1, ऑप्शन डी ऑल ऑफ द अबव। एंड से कहबे किछि बढ़िया दरकार नै साइंस एंड टेक गो फॉर ऑल ऑफ द अबव। तो बर्तमान मते को ऑल ऑफ द अबव हो कि खबर नहीं ना? ओके नेक्स्ट, यूएस लैब मेक्स हेडवे इन न्यूक्लियर फ्यूजन एनर्जी, हाउ मच इज देयर फ्यूजन रिलेटेड? okay, maybe we'll try to discuss it tomorrow again. Okay, 10. Hope it is clear, right? Difference between fission and fusion. And in fusion we are trying to talk about hydrogen bomb, and for hydrogen bomb we require atom bomb, that means uranium 235. Clear? Okay, chalo, thank you everyone.